Right, in this video we will try to evaluate this integral. The first thing we have to do, I'm going to assume that we all know that because the derivative of ln x, so if y is ln of x, then dy by dx is 1 over x, right? So if y is ln of x, then the derivative is going to be 1 over x. I'm going to hope that we know where this comes from, but just in case, let me just assume that we don't. Then we can write this expression as e power y is x, all right? So dx by dy is e power y, okay? So dx by dy is e power y because the derivative of e power y is e power y if we are differentiating with respect to y. And so if I reciprocate this, then I have dy by dx is 1 over e power y, and 1 over e power y is x, so this is 1 over x. So this is in fact 1 over x because e power y from here is 1 over x. So therefore, if y is ln of x, then dy by dx is 1 over x. But differentiation is the reverse of integration. It follows that. So if I have ln of x and I differentiate, I will get 1 over x. Then it follows that if I go in the reverse and integrate 1 over x, I should get ln of x, usually plus c. All right, so the integral of 1 over x dx is clearly ln of x, and we add the constant c because we do not have the limits of integration. If the denominator there is a bit made slightly more complex, we turn it into a linear function with a constant value of a other than 1, like this, ax plus b dx. Then we can use a method of substitution, and that will show us, or that will give us 1 over a, this a here, ln of the same thing, ax plus b plus the same constant there. So this is the only difference if the denominator, the coefficient, there is a coefficient of x other than 1, all right? So like that. So with this information, it should become easy for us to solve this integral. Let's see how we do that. So keep these two pieces of information in mind, and let's now see how to integrate this function. Right, so the first thing we want to do really is to express this, the denominator as factors. So I can write that 1 over 4 minus x squared, we can express this as 1 over 2 minus x into 2 plus x, like that. That's the denominator. The denominator is a difference of two squares, and therefore it can be written, can be expressed as binomial conjugates. And now what I'm going to do is to split this into partial fractions. That is, let this be a over 2 minus x, and I'll say plus b over 2 plus x. And my job now is to find the right value of a and b that will make these two fractions be equivalent to that. Now to do that, I cross multiply. This is common, that is common. So I can express this as 1 over 2 minus x. We could do this in one line, but just to explain, let's try to do it in a slightly longer. So this is the same as 2 minus x. I'm combining the denominators here, the denominators of this, and so the same way we add fractions, this becomes a into 2 plus x, and then we say plus b into 2 minus x, the way we add fractions. Okay, and that means that this can now be, we can now express, just relate, since the denominators are the same, the numerators can be expressed as 1 is equivalent to a into plus x plus b into 2 minus x, like that. Now to find the value of a and b, I need to eliminate a and b one at a time and find the other. So if we let x be minus 2, right? If we let x be minus 2, the left-hand side of this expression remains 1, but the right-hand side, this is negative 2. So that makes a disappear because 2 minus 2 disappears. But b is now b into 2 minus minus 2, which is 4b, which is to tell me that b is actually 1 over 4. Similarly, if we let x be positive 2, then the left-hand side becomes equal to 4b. Just check that out. I mean 4a. If you check that out, you can see b disappears. B disappears because we put 2 there, so now 2 minus that, so this becomes 4a, and this therefore tells me that a is 1 over 4, like that. So now I know these values, so I can remove that, and now to determine my integral, I'm looking for the integral of 1 over 4x, 4 minus x squared dx. This is the same as integral of, well, that is now 1 over 4, so I can put 1 over 4 outside, and I do integral of 1 over 2 minus x dx, and I can say plus 1 over 4 integral of this b here, which is 1 over 2 plus x dx. All right, now if we remember our results for the derivative of ln of 1 over ax plus b, that tells me that this, let me write here now, that tells me that this becomes negative because a is negative, the coefficient of x here is negative, so therefore that's going to be 1 over, remember, integral of 1 over ax plus b dx. This is going to be 1 over a ln of ax plus b plus c. So keeping that in mind, where a here is the coefficient of x. Our coefficient of x here is negative 1, and so this therefore becomes negative 1 over 4 ln of just 2 minus x. And this becomes positive 1 over 4 ln of 2 plus x plus c. And that is actually the answer, but the examiner might say compress it. If that is the case, then these two can be compressed. 1 over 4 is common, so it goes out. This is added, this ln is added, that one is subtracted, and that means this is ln of 2 plus x over 2 minus x, everything plus c, and that becomes the answer to this integral. Okay, let's look at the next. Okay, let's see this one. There is a difference between this one and the first one, the first integral that we just solved. Now we have an x squared at the top. When we have a question like this, it's the better thing to do is to first reduce it into the form that we had earlier, where this was 1, because the numerator, these are quadratics or polynomials in the numerator and denominator. Basically, we are talking of a rational function as the integrand. So to solve this, we need to divide. Since the order of the numerator and denominator are the same, what we can do is to divide. We cannot use substitution here because we don't have a function and its derivative. All right. So the best thing to do is to first divide, use long division to divide the numerator with the denominator. So that is to say that I can, let's just move on to a new page. So that means I can write so x squared over 4 minus x squared. So I can write this as 4 minus x squared. I'm going to do long division, so x squared there. So in the forward direction, negative x squared goes into x squared negative 1 times. Then we multiply back and we get x squared, this times that, and we say minus 4. Then we subtract, this disappears, x squared minus x squared disappears, 0 minus negative x squared becomes 4, and that's it. This does not go here anymore, and so we can write x squared over 4 minus x squared is the same as negative 1 plus 4 over 4 minus x squared. That's really it. And so if we're going to find the integral of x squared over 4 minus x squared dx, this is just going to be the integral of negative 1 dx plus 4 integral of 1 over 4x 4 minus x squared, x squared dx, like that. Well, the integral of that is simply minus x plus c. We will put 1 plus c, and then we say plus 4 into this integral, which we've actually found earlier in the previous question. If I remember correctly, it was 1 over 4 ln of 2 minus x, 2 plus over 2 minus x, all right, like that, plus c, and then we can put all together plus c there. All right, this is the result. I can simplify that, but effectively it's done. So it's just 4 goes in there, and we have ln of 2 plus x over 2 minus x, all right? And we should have plus 4c, which is just another constant. So first of all, we can say minus x, and then we say plus an overriding constant from here and that, all right? So this then is the result of this integral here. Yes, hoping that makes sense. Let's look at the next. Evaluate the integral of, well, the integral shown there. Again, in this question, you can see that the denominator there is actually a perfect square. So, here we go. What we have is 1 divided by 25 plus 10x plus x squared. All right, so this is a perfect square there, and I can write this as 1 over x plus 5, I believe, squared. Okay, so 1 over x plus 5, x plus 5. So this is the same as integrating 1 over x plus 5 squared dx, which is, if we let u be x plus 5, then du by dx is 1, du by dx is 1, so du is equal to dx, which is to say we can substitute where there is dx, I can just put du there, and where there is x plus 5, I can put u. So this becomes integral of 1 over u squared du, which is the same as integral of u power minus 2 du, which is really straightforward. This is the same as minus u power negative 1, all right, plus c, which is the same as minus 1 over u plus c, which is in fact minus 1 over u was x plus 5, right, because u was that, and then we say plus c, and this is the integral of that. It is just that straightforward. Okay, so this required us to factorize the denominator, makes life easier for us like that. Yeah. Let's see the next one. So next we solve this integral here. This is a bit different from the first two in that in the denominator now we have plus. So we cannot factorize the denominator anymore. It's not a difference of 2 squares, but we can divide the same way that we divided, I think, the second one we had to divide so as to ensure that the power of the numerator is less than the power of the denominator. So if we look, we use a long division, we can divide that integrand. So I'm going to write the integrand is, we have x squared over 4 plus x squared, right? So if we divide this like before, we have 4 minus x squared, that's still visible, x squared, this is plus now, so x squared goes into x once, 1 multiply back, here gives me x squared, but if we multiply there, it gives me plus 4. If we do subtracting as before, this is 0, and this is 0 minus 4 is negative 4 there. So I can conclude that x squared over 4 plus x squared is the same as 1 minus 4 over 4 plus x squared. All right, and therefore the integral of x squared over 4 plus x squared dx is simply the integral of 1 minus 4. In fact, I'm just going to write I'm going to split it up so we can deal with them separately. So it's going to be 1 dx minus 4 into 1 over 4 plus x squared dx. This is now easier to integrate. The first integral there is just x, and we say minus 4. To integrate this term, we can use, clearly, we can use tan-substitution. So I'm going to leave this for the moment, and then we do tangent substitution. So if we let x, I'm going to write here, let x be, because that is 4 there, I'm going to say 2, and I will say tan x. And what a tan u, or tan theta. And why am I using tangent? Because I know I'm going to have 1 plus tan squared here. Okay, so I've put 2 here so that when I square, I'm going to have 4, and then I can factorize that 4 out, and I will remain with 1 plus tan squared of x, like this. So, integral of 1 over 4 plus x squared dx, this becomes integral of dx. If x is tan that, then dx, if I differentiate, I get, let me remove this first. So we differentiate, we find the substitution for dx. So if I differentiate this, dx by d theta, or just dx is twice the derivative of tan is sec squared of theta d theta. So dx is 2 sec squared d theta. And so my integral now, this thing here, where there is dx, I remove and put 2 sec squared theta d theta. I'm taking the 2 out. It doesn't take part, and this becomes 4 plus x squared becomes, this is x, so if I square, I get 4 tan squared of theta. All right, I already have my d theta there. And now I can factorize 4 out, so I have 2 over 4, which can simplify later, and this is sec squared of theta d theta, but the denominator now is 1 plus tan squared of theta. Now, you would probably already know from the Pythagorean identity of trigonometric identities that sec squared theta is the same thing as 1 plus tan squared of theta. So therefore this term here is effectively the same as that, and that means that this is just a half integral of d theta, which is the same as a half theta plus c. All right, now we need to know what the value of theta, we have to get it back to sine so that it is in terms of sine. That is our substitution there. So we can see that our x was 2 tan of theta. So tan of theta is a half x, or x over 2. And so theta is arc tan. Hope this is still visible. Half tan x over 2, like that. And because of that, my answer is now a half arc tan x over 2 plus c. This is our integral. Now we have to add this here, so we will have that times, I hope this is not very confused, the board appears really confused. So this is the result for this part here, and so I can write 4 there, and then I put times 1 over 2 arc tan x over 2, and we say plus c. This is the effective integral. We can simplify, of course. This becomes x minus 2 arc tan of x over 2, everything plus c. Well, the solution is a bit all over the place, but hopefully you can understand what's going on. That's how we solve this. It's not really difficult. All right, let's see. I believe there's a last one that we can look at. Sorry about the confusion here. All right, so here is the last question. We want to integrate this. Probably just need to give a hint here. Somebody can already see that this is also possible by just factorizing the denominator there. So if we factorize the denominator, let me write the expression. It's x squared plus 3x in the denominator. So we have 1 over x squared plus 3x in the denominator. We are going to integrate that. But before we do that, we factorize the denominator and we get 1 over x into x plus 3. So here is a case where again you express this as partial fractions. A over x plus b over x plus 3. All right. In one step, this is 1 equals a into x plus 3 plus bx. So basically this multiplies this and this multiplies that, and we equate to 1 there. These are equivalent. So to get rid of b, of course, I can let x be equal to 0. If I do that, I get rid of b and I have 3a. So a is actually 1/3. Similarly, if I make x be -3, if we let x be -3, then I can get rid of a here. So the left-hand side becomes equal to -3b. So b is -1/3. That's all. And that means the integral of 1 over x squared plus 3x dx can now be expressed as 1 over a, so that is 1/3, okay, 1 over x dx, and it is minus 1 over 3, minus because of this, and integral of 1 over x plus 3 dx. And if you've been watching these videos from the beginning, then you know that this just reduces to 1/3 ln of x, okay, and this becomes 1/3. A is 1, so 1 over 1 doesn't matter, and this becomes ln of x plus 3, and we say plus c. All right, we can put this together. This is already enough. It's the solution, but we could put them together, and we have factorize 1/3 out, and we have ln of this is added, so x goes up. This is subtracted, so x plus 3 goes down, and we say plus c, and that's the integral of that expression there. It is that easy. Okay, so most of the questions we've just looked at are about factorizing the denominator, splitting into partial fractions, and then finding the integral from there. All right, thank you. I hope you were able to understand this. If you need me to answer any question, any integral question, let me know. But these are generally easier than normal. All you need is to do a bit of practice. So none of them really required any particular trick. All right, there will be integrals that require a bit more tricks. There will be cases where you cannot factorize that if it is quadratic, but you cannot factorize it like this. But any quadratic can be converted to the vertex form. If you've turned it into a vertex form, then we can still use the tan or sine or cosine substitution to solve them. So let me know if you have any more challenging integral questions, and I will be able to help. All right, thank you very much.